Okay, I am going to do my experiment on liquid carbon dioxide. The 4 jars or glasses that you see have soda water in them. You see the bubbles. That is the carbon dioxide. I'm going to use spaghetti first. I'm going to take some spaghetti. I'm going to break them up in some small little pieces. And I'm going to put them in the first glass and see what happens to these little pieces of spaghetti. And see if what happens. There's a lot of bubbles. We see the bubbles happening. So, and we are starting to see the spaghetti rise or dance around. There's little bubble or sticking to the bubbles, the carbon dioxide. That's what's happening when you see the bubbles around it. So let's try the raisins next, because we've heard of dancing raisins. So let's see what happens. Let's see. Whoa, there's a lot of, and immediately, there's a raisin that just goes straight to the top immediately. Didn't waste any time, did it? So this, what happened here with this raisin, the bubbles, I guess, since the raisin's rough, it hooked immediately, and in every little rough nook and cranny of that raisin, the bubbles hooked on or attached to. It almost looked like it was building a wave too, the way it just kind of, you can see the bubbles are different in the raisins than you can the spaghetti. It's just a constant flow and almost like a wave. So anyway, now let's look at, well, the raisins, well, let me go back to the raisins. The raisins do have a greater volume, and they displace more water, so causing the greater buoyant force. And that buoyant force is what helps push to the top, the raisins to the top. The top of the bubbles pop when they're exposed to the air, and they become more dense, causing them to sink. So this is what makes that go up and down. You see these raisins going up and down. The more bubbles, the more density decreases, and it rises to the surface again. So that's why it just keeps going back and forth. It attaches like life jackets. That's what the bubbles are attached, and then I guess it's like a life jacket. So it makes the raisins more buoyant by increasing their volume. So it kind of reminds me of when I went water rafting and I had a life jacket on and I was underneath the boat and I couldn't get up. And then all of a sudden, just something happened where the boat moved a certain way and I was able to finally get up. And when I did, I just immediately just popped up out of the water. Just with that buoyant force. I just feel like it was just a force of just popping up out of the water. Let's go back and let's see if we can try some beans. Just to see what happens. Some lentil beans. We see it? They bubble a little bit. And they're kind of moving. There they are. They are starting to go up. Oop, I think I got a raisin in there too. But they are going up and down and they're dancing. Let's see some craisins. Because I think craisins might be a little bit better. They're not as thick and rough in mass. So let's try the craisins and see what happens to those. You see those little bubbles attaching to the raisins or the beans or the craisins or the spaghetti. You can see that the carbon dioxide is attaching to that. You can see that. So anyway, so that's what the carbon dioxide it does. Now, if we break the surface tension, like now the spaghetti is really not doing a whole lot. So I'm going to break the surface tension by throwing in, like, say, I'm going to throw a couple craisins in. Let's see if we can get it going again a little bit more, because right now they're kind of at a standstill. Let's see. I break the surface. See if I can get the spaghetti going again. I got the craisins going, but not the spaghetti really. Let's see. See if I can get the raisins going. If I throw a little bit, kind of mix and match my food just to kind of break it up a little bit. See if I can get things going again. And it is, they're going. Now these tiny bubbles of carbon dioxide gas, they're attached to all these foods, and those bubbles increase in volume, but contribute very little to its mass. So the overall density of the macaroni or the raisins or the beans, the density of is lowered. And this is causing it to be carried upward by more dense fluid. So that's why it just keeps going up and down. And I was able to break the surface for a little bit, and it's able to do a little bit more dancing. How long? I mean, if we put a lid over it, eventually it would stop. If we put a lid on these glass, because that carbon dioxide would stop. Wouldn't have the fizz, and the bubbles wouldn't be attached to the raisins or the beans or the craisins or the spaghetti. I don't know if I tried elbow macaroni. Let's try that real quick and then we'll end this. Let's see what happens to elbow macaroni. If it goes up or does it just stay in sync. I do see bubbles attached to it. But not as fast as the others. The craisins definitely. Now there's a macaroni that goes up, but it's attached more to the craisins. And they're dancing, and they're in like little, sometimes in 2s and in 3s. So there we are. There we have it. And that is my project on carbon dioxide, the liquid, and what those gases and the bubbles are doing to attach to the product. Thank you.